Hi folks, I hope you're doing well today. What we want to talk about this time is a system of linear inequalities. Okay, so there's a lot going on there. System, meaning more than one equation. Linear, meaning the equations are straight lines when you graph them. And inequalities means you either have a greater than, a less than, a greater than or equal to, or less than or equal to. And there's one coming up. Here we go. That is a system of linear inequalities. That's an example. So notice you have the inequality 6x minus 5y is less than 20, and negative 2x plus 7y is greater than negative 8. Now I know this is linear because the exponents, the x is raised to the first power, the y is raised to the first power, and that's for both equations. So if this is the situation you have, you're dealing with straight lines. And then finally, the inequality, you got a less than and a greater than. So what is a solution to a system of linear inequalities? Okay, well, a solution is an ordered pair, an x and a y value, that make both inequalities true. Not just x and y's that make the first one true, but x's and y's that make the first and the second one true. So a point, x, y, an ordered pair, substituted into either of these will make a true statement. So I have a problem for you finally. Is 1, negative 3 a solution to the system above? How do you find out? You just substitute it in. So my x is 1 and my y is negative 3. And when I substitute x equals 1 into the first equation, I have 6 times 1 minus 5, my y is negative 3. Is that less than 20? That's the question. Okay, well, we have 6 times 1. Remember, you multiply before you add or subtract is 6. Think about this as a negative 5 times the negative 3, which is a plus 15. Is that less than 20? Well, 21 less than 20. It's not true, right? This is a false statement. So we know that not only is 1, negative 3 not a solution to the first equation, it's not a solution to the system either. Now you could check the next one, but it's pointless because it didn't even make the first equation true. You understand? So when you check your xy value, if it's a system, it makes both inequalities true. So here we are. I have another example. Notice it's the same system. 6x minus 5y is less than 20. And negative 2x plus 7y is greater than negative 8, but I have a different ordered pair. I have the point negative 4, negative 4. My x is negative 4, my y is negative 4, and I would like to see if this is a solution to this system of linear inequalities. So I have 6, I'm going to replace my x with negative 4, minus 5, I'm going to replace my y with negative 4 as well. Is that less than 20? That's the question. So 6 times negative 4 is negative 24, minus 5 times negative 4. Again, you can think about that as subtract 5 times negative 4, and that's going to turn into a plus 20, or you can think about it as negative 5 times negative 4 is plus 20. Now, negative 24 plus 20, remember you subtract when you have opposite signs, so 24 minus 20 is 4, but the heavier one is negative 4 less than 20? It sure is. Which means I need to move on and check the second inequality. So negative 2, I'm replacing my x with negative 4, plus 7, replacing my y with negative 4. Is that greater than negative 8? Well, we're going to find out. Negative 2 times negative 4 is 8. 7 times negative 4 is going to be a negative 28. Now 8 minus 28, or 8 plus a negative 28, if you like, is negative 20, and that is not greater than negative 8. Okay, so the answer, is this a solution? No, it's not, because it made the first inequality true, but not the second one. Now, I'm sure you've seen enough of this question, but one more time, is a third try, negative 4, positive 4, an ordered pair, is it a solution to the given system of linear inequalities? So this time my x is negative 4, my y is positive 4. I have 6 times x is negative 4 minus 5 times 4 Is that less than 20? Now 6 times negative 4 is negative 24. Minus 20, is that less than 20? It is, because you can think about negative 24 plus a negative 20 is negative 44, and that is definitely less than 20. Now let's try the second inequality. So negative 2 times negative 4 plus 7 times 4, is that greater than negative 8? Then negative 2 times negative 4 is 8, plus 28, is that greater than negative 8? And 8 plus 28 we know is 36, is greater than negative 8. Sure is. So finally, yes, the ordered pair negative 4, 4 is a solution to our system of linear inequalities. Alright, so I have another example for you. It's a different system. Y is greater than 4x minus 2. Notice the y is to the first power, the x is to the first power, so this creates a straight line if you were to graph it. And because it's an inequality, it's a straight line where one of the sides is shaded. The same thing with the second inequality. Again, x is to the first power, y is to the first power, so I know it's linear, or a straight line. And since it's an inequality and not an equals, it creates a line that one side is shaded. And we'll talk more about that in a minute, but all I'm really asking you here is x equals 2 and y equal 1 a system to that solution? So I say 1 is greater than 4 times 2 minus 2. Is that true? Is 1 greater than 4 times 2 is 8 minus 2? Is 1 greater than 6? It's not. You know what that means? There's no point in even checking the second one. Now, what if you made a mistake? It may be worth redoing the first one just to be sure. And y is 1, 4 times 2 is 8 minus 2 is 6. No, it's still not true, so it's worth checking it again to make sure you didn't make a mistake. But if it doesn't make one of the equations true, then it's not a solution. So let's check the second problem, a completely different problem. Oh, no, it's not. I'm sorry. It's a completely different ordered pair. It's the same problem, though. So 4, negative 1. In this case, our x is 4, our y is negative 1. So in the first inequality, I have y, which is negative 1, greater than 4 times x is 4 minus 2. Is negative 1 greater than 16 minus 2? And we know 16 minus 2 is 14. Is negative 1 greater than 14? No, that's not a solution either. I thought for sure out of those two examples, by the way, I often get these out of the book, that at least one of those would be true, but both of these points failed the first time, and I checked it again just to be sure, and yeah, it's not true. So that means neither of these points are a system to that solution. So that comes to the question that I hinted at a minute ago. What does a solution to a system of linear inequalities look like graphically? Okay, now linear means straight line. So we're dealing with two straight lines in the same plane, or the same xy axis, and they're shaded. Remember, when you graph an inequality, you shade one side of that line. So picture two of those situations in an xy axis. So let's kind of talk ourselves through this. So I have an example for you here. I have the linear inequality, y is greater than or equal to negative 2/3 x plus 2. Okay, so we know that all the solutions of a single linear equation create a straight line. And there's our straight line right there. If you need a little bit of help remembering how to do that, the y-intercept right here is 2. So that's the first thing I do, is graph the y-intercept here. And then my slope is negative 2/3. So I count down 2 from there and right 3. And that would take me to this point. I could do it again, down 2, right 3. And that creates that point, and you connect the dots. Now, because this is a greater than or equal to, I connect the dots with a solid line. That's here. Now, the next thing we have to do over here in green is shade the side of the inequality that makes it true. Now, how do we figure that out? Well, here's what you do. You pick a point that does not lie on this line. I always use 0, 0 if I can. And 0, 0 right here does not lie on that line. Now, plug that into your inequality. Is 0 greater than or equal to negative 2/3 0 plus 2. And 0, that says 0, this of course is 0 greater than or equal to 2? It's not. That means I do not shade this side with 0, 0 on it. I shade this other side. And it looks like that. Okay? So we have, that is one, well, that is the solution to this one linear inequality. Now, what if I go and throw a second inequality into the mix? Okay? Here we are. So in green over here, to make it a system, we graph another inequality. So we've got y is greater than 2x minus 3. Let's talk about how you would graph that. So my y-intercept is negative 3. So I go down to negative 3. Here's negative 3 on the y-axis. And my slope is 2. Remember, you could write that as 2 over 1. So I am to count up 2 and right 1, up 2, right 1. Okay, keep doing that, right 1. And that gives me, a little bit squirrely, but this line right here. Now, here's the thing. This is greater than, so instead of a solid line like I did, I really need a dashed line. So it's going to look like this. Okay? So anytime you have a greater than or less than, you do a dashed line instead of a solid line. So next we have to find out which side to shade, okay? So once again, and now again, what's here in the reddish orange color, I'm ignoring that for now. I'm just working on my green, y is greater than 2x minus 3. Now, 0, 0, and again, it's my go-to to test, is not on my line. Everybody agrees it's not on the line. So what I'm going to do is say, 0, is that greater than 2 times 0 minus 3? And 0 is greater than negative 3, right? This is true. And 0, 0 is right here, so that means I shade this side. All of that. Okay? Now, I've got a better version of that. I'm going to show you on the next page. And it's right there. So you see our dashed line. I just changed it to blue instead of green. Now, my real answer is what's shaded in both colors. Okay? So all of this right here, I'm shading it again. Now the dash part is not included in your answer, so it goes right up to the dash part and stops. But what I've got shaded here, that is the final answer to that inequality. Okay, that system of inequalities. It makes both true. So what ends up shaded both colors is your final answer for that system. So let's try a problem or 2 or 3. All right, here we go. So you'll see we have a system because we have 2 inequalities. I know it's linear because x is to the first and y is to the first. I know it's an inequality because it doesn't have an equal. It has a greater than. The second one, the same thing. Y is to the first, x is to the first. I know that it's an inequality because it has a less than. So let's think about these separately. So I have x minus y is greater than 3. Now, how do we want to graph that? I'm a big fan of writing everything in the form of y equals mx plus b. It doesn't always work. Watch this one. I'm going to move that x over. That'd give me negative y is greater than negative x. Matter of fact, let's don't even worry about the greater than right now. Okay? Graph an equal to instead. It's less confusing. Okay? So I have negative y still on the left. I move my x over, makes it negative x plus 3. I have to get rid of the negative. So I divide every one of these terms by negative 1. That gives me y is equal to positive x minus 3. There's a faster way to get there, and if you notice that by adding the y and subtracting the 3, that's fine. Now, I need to graph this with a dashed line. I do recommend you writing that down because when you go to graph it, you'll forget to do the dashed line. Now, my y-intercept is negative 3, so I start at negative 3 on my xy axis, and my slope, my m, is 1 because the coefficient of x is 1 over 1. So I rise up 1 and I run 1 from negative 3. So up 1, run 1, up 1, run 1, up 1, run 1. I could even do the opposite and go down and left. So down and left, that means they're both negative, but that still gives us 1. Dash line. There we go. Okay. Now I'm going to graph my other inequality. I'll do that one in green. So I'm looking at y is, better yet, before we even do that, let's shade. Okay. Let's finish up this process. In red, we've got to figure out what side to shade. Now that's when you go back to your original inequality. Okay, you can't shade with an equals. You have to go back to your original. Now you need a point to test. I always go with 0, 0 if it's not on the line, and 0, 0 is not on the line, and plug it in. So x is 0 minus y is 0. Is that greater than 3? Well, that says 0 is greater than 3. We know that's false. So I don't shade the side that 0, 0 lives on. I shade the other side. So basically the lower right part of the xy axis. And there we go. Now I can change colors. And let's do green for the second equation. So I have y is equal, remember you change it to an equal to graph it, negative 1/5 x plus 4. Now, because it's a less than, there's no equal to. That means we're going to do another dashed line. Okay. Now, here's what I know about this thing. My look, it's already in y equals mx plus b. So my y-intercept is 4. So I start at 4. And my slope is negative 1 over 5, which means I can go down 1 and right 5. From my y-intercept. So I count down 1, right 1, 2, 3, 4, 5. Do it again, down 1, and then 1, 2, 3, 4, 5. You could also do the opposite. You could go up 1 and left 5. That would be the same as saying 1 over negative 5. So up 1, and then 1, 2, 3, 4, 5. And then up 1, and 1, 2, 3, 4, 5. And a dash line to connect those dots. Connect my points, arrow on each end. Now I've got to figure out what to shade. So if I shade, 0, 0 is my test point. Notice 0, 0 is not on my dash line. So I go back to my original inequality. Is 0 less than negative 1/5 times 0 plus 4? And that's saying 0 is less than 4 because that's just 0, right? And 0 is less than 4. So 0, 0 is, looking at the green line. Ignore the red for now. Pretend like it's not even there. When I'm looking at my green line, I'm talking about lower left. So I'm shading all this in. You see that? Now my answer is what's shaded for both of them. And I'm going to try to highlight that for you. It looks like a Christmas tree threw up on the graph. But here we go. Notice that all of this is shaded both colors until you get to the green dash line right there. So I do mean intentionally to leave that out up above. And that bright yellow highlight is my final answer. Okay, let's try another one. Alright, so if the video did weird there for you just a minute, and my screen messed up, so I had to get back to it. I apologize. Now, I'm working on my first inequality. I made it in equals. Okay, and this is what I'm attempting to graph. Now, you can put that in y equals mx plus b form, but don't forget that a tool that you have is just calculating the intercepts, and that's a real easy method for this particular problem. So notice intercepts. Remember, if you let x equal 0, you find the y-intercept. Well, if I let x equal 0, that's gone. That gives me negative 2y equals 6 divided by negative 2. That's y equals negative 3. So that's the point 0 for x, negative 3 for y. Okay, just using the intercepts. And now if I let y equal 0, that means this is 0, right? The negative 2y is gone, and that gives me 3x equals 6. Now, if I divide both sides by 3, that gives me x is equal to 2, and that will give me the point 2, 0. That's the intercept method, okay? And it's a little bit faster than trying to put that thing in y equals mx plus b form. Now, do I need a solid line or a dashed line? Well, look, How do I decide? That's less than or equal to. If it has an equal to with your inequality, then you need a solid line. And maybe we should have said that first. So solid with this guy right here. So I connect the dots with my solid line, and it pretty much looks like that. Now, don't jump away too quickly. We've got to decide what side to shade. So I'm going to test the point 0, 0 because it does not lie on my solid line. And I'm going to plug it in for x and y. So 3 times 0 minus 2 times 0, is that less than or equal to 6? Now notice it's different than finding the x and y intercepts. To find the x-intercept down here, you let y equal 0. To find the y-intercept, you let x equal 0. But not 0, 0 at the same time, which is what we're doing when we test a point. And this is 0 is less than or equal to 6. Is that true? Sure it is. So 0, 0 is on the top side. So that means I shade all of this. Okay? Forever. Now, let's do in a different color. Let's use blue this time for my second inequality. And I'm going to say y equals, just to graph it, negative 1/4 x plus 5. But this thing is dashed, right? How do I know that? Because I'm looking at there's a greater than, there's no equal to with it, which means I need a dashed line. Now this is already in the form y equals mx plus b. Your b value is 5, so I go up to 5 up here in blue, and then my slope is negative 1/4. So that means I can go down 1 and right 4. I could do the opposite too. I could go up 1 and up 1 and left 4. Or we could do both. So let's go down 1 and right 4. 1, 2, 3, 4. Looks like that's on my line. My line's off. Down 1, 1, 2, 3, 4. Or I could do the opposite. We could go up 1 and left 4. 1, 2, 3, 4. And again, I connect those with a dashed line. Not finished, because I have to shade. Question is, do I shade above my blue dashed line or do I shade below my blue dashed line? Well, to find out, I plug in a test point. I'm going to pick 0, 0. Okay, so 0, 0 right down here. And is 0, go to the original, greater than negative 1/4 times 0 plus 5. And look, 0 is not greater than 5. Remember, that's 0. Okay, that's false. So I don't shade the side with 0, 0 on it. I shade above. So we're talking about everything above and to the right of the line. Now, my final answer is what's shaded in both colors. So if you'll look, this is all shaded in both colors, all the way until you get to the red, shaded in both, and there you go. So this highlighted that I got here, that is your final answer. It's what's shaded in both colors. So now we're experts, right? Yes, we are. So x is greater than negative 4. That's definitely linear because it's x to the first power. I'm going to graph x equals negative 4 instead. I'm going to do it with a dashed line. Why dashed? Because it's just got a greater than, no equal to here. Well, what does x equals negative 4 look like? I hope you all remember that x equals negative 4 is a vertical line. If you're ever missing a y value and you just have x equals, then it doesn't matter what y is. So basically a vertical line at x equals negative 4. Why am I doing dashed? Oh yeah, right, because it's x greater than negative 4. So what do I shade if I'm talking about x values greater than negative 4? Well, anything bigger than negative 4, right? That's to the right. Now, you could test 0, 0 and plug it in, but anything on the 0, 0 side is bigger than negative 4. So there we are. First one done. Now let's go blue. The second one, I have x minus 2y. I'm going to change it to an equals just so I can graph it, negative 4, but this time we do solid. Why solid? Because of the equal to part with it. Now this is not in y equals mx plus b. We could put it there fairly easily, or we could find the intercepts again. It works out nicely. If you don't get fractions for your intercepts, it works out pretty good doing that. This is really entirely up to you. Let's do the intercepts again. To do that, to find the y-intercept, you let x equal 0. All right? So that means this is 0. That just gives me negative 2y is equal to negative 4. I divide by negative 2 on both sides. That gives me y is equal to 2. And remember, that's the point 0 for x, 2 for y. So I'm going to plot that point, 0, 2, right up here. Then I'm going to plug in y equals 0. So that's going to give me x, that's 0, equals negative 4. Well, okay then. X equals negative 4, that's the point negative 4, 0. That's right here. It's actually where the two lines cross each other. And I'm doing a solid line. So there's a rough version of what that looks like. But don't forget to shade. Okay, so remember, I'm going to test 0, 0 because it is not on my blue line. So I plug that into my original. So way over here, my original problem right there. Okay, so 0 minus 2 times 0, is that less than or equal to negative 4? Well, all this on the left is 0. Is 0 less than or equal to negative 4? No, it's not. Nope. All right, so that means I don't shade this side with 0, 0 on it. I shade the other side, so top left. So all this above the blue line, all of this, is, or makes that true. Now, can you see what is shaded both colors? I know it looks like a train wreck. Shaded both colors, I'm going to do this in bright green, is down the dash line, not including the dash line, and all of this. Now I got a little carried away down here to the right on top of the line. I didn't mean to shade so far down. I could attempt to fix that. I might make a mess of it. We'll see. Yeah. I picked the wrong eraser. Okay, hold on. Hold on, bear with me. I can't stand it. It was all of this. And not only that, did you see? I lost all my red too. I made a total disaster of it. Okay. Just to make myself feel better, you ignore me. I'm going to fix the red. Because remember, it was everything to the right of negative 4. There we go. Put the bright green as our answer. Okay, are you getting the hang of it? Let's do 2 more problems. Okay, so we have a system because we have 2 inequalities. They're inequalities because we have a greater than and a less than, and they're linear because all the variables are raised to the first power. So we know we have straight lines, nothing to worry about there. So I start with x plus 3y. I'm going to change that to an equal, but I'm going to remind myself that that is a dashed line because of the greater than, no equal to there. Okay? Now, how do you want to graph it? Entirely up to you. Let's go back to y equals mx plus b. So I'm going to move that x to the right. You know, when you move a term to the other side, it changes the sign. So it's a plus x over here. When I move it to the right, it turns into a negative x. The plus 8 is still on the right, so it stays. Divide everything by 3 to get that y by itself. So I have negative 1/3. Remember, there's a secret 1 in front of that x. X plus 8/3. Well, pooh, you know why? Because I can't graph 8/3. Now, I can do it here, but y'all, if you're doing homework online or using some sort of computer algebra system, you may have trouble graphing these fractions. Okay, so what can we do? We need nice numbers. You know what? We're just going to have to let that one go, because even if you find the intercepts, you're going to end up with that 8/3. You can work real hard to try to figure out some numbers to plug in, but let's just keep it the way it is. It's going to be okay. If when I usually copy these problems out of the book, if I would have realized I could have changed that to a 6 and solved a lot of our issues, but I'm going to keep it 8/3 because this is real world what happens. You know how big 8/3 is, right? 3 goes into 8 2 times with 2 left over, so that's really 2 2/3. I'm going to go up here to 2 and about 2/3 and make my dot. And then I'm going to count down 1 and right 3. And you say down 1 from there, and my dot disappeared. There's 2 2/3. There it is again. I'll make it bigger. There it goes. Okay. Now, I can count down 1 from there. It'd be 1 2/3, and then write 3. 1, 2, 3. I could do it again. So down 1, which would be just 2/3, and write 1, 2, 3. There we go. Remember, this is a dashed line. Good enough. Now, we shade. 0, 0 right in the middle. The origin is not on my dashed line, therefore I can use it as a test point. I'm plugging that directly in. 0 plus 3 times 0, is that greater than 8? It is not, so I don't shade the 0, 0 side. I shade up and to the right of my dashed line. By the way, there are other methods for handling that. When it's in the form of y equals mx plus b, you can sometimes think about the arrow there, but I suggest picking a point and shading. It'll help you with other types of problems. Now let's move on. How about y is equal to negative 1/3 x minus 2? Okay, now I need a dashed line here as well. Alright, so my y-intercept is negative 2. Down here. At least it's nice, not like 2 2/3. Now I count down 1, write 3. Down 1, write 3. Down 1, write 3. Oh, I didn't go far enough. I've got stray marks on here. Down 1, write 3. I could also go up 1 and left 3 if I want to. Now, there's something really important here I want you to see. What's happening with these two lines? If you said they're parallel, ding, 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 good job, because the slope is negative 1/3 for both of these. These guys do not intersect, and that's okay. Okay. I do have to figure out what to shade. Remember, 0, 0 is not on that line either, on the blue line, so I'm going to plug in there to test. So I have 0, is that less than negative 1/3 times 0 minus 2? Is 0 less than negative 2? No. It's not, right? So I don't shade above, I shade below. Alright, now remind me, what's the answer? The answer is what shaded both colors. Is anything shaded both colors? Ah, you know what? There's no solution to this problem. No solution at all. There are no ordered pairs, which means a point in the xy axis that is shaded both red and blue. So there is no solution to the system. If you were typing that in, it would be just a big old empty set. And by now you have it. I know you do, so I'm not going to torture you much more, but one more problem. Okay? So I have my first inequality. It's linear because y and x are to the first power. So I'm going to change this to an equal just so I can graph it. Now, do I need solid line or a dash line? Solid, you say. You are right, because of the equal to with it. So that means anything on that line is included in your answer because it's solid. A dash line would mean you go up to the line but don't include the line. So it's solid. It's already in awesome y equals mx plus b form. So my y-intercept is 2. So I make my mark at 2. And then my slope is negative 1/4. So I can go down 1 and right 4, right positive. Or you could go take the negative to the bottom and you could go up 1 and left 4. It gives you the same line. Try it. Okay, so from there I count down 1, right 4, 1, 2, 3, 4. I could do it again. Down 1, 1, 2, 3, 4. Or I could go up 1 and left 1, 2, 3, 4. I could do it again. Up 1, 1, 2, 3, 4. There we go. And then I connect that as a solid line, which means all the points on that line are part of my answer. Don't forget to shade. I got to decide which side to shade. 0, 0 does not lie on my red line. Therefore, I could use it as a test point. You might be thinking, what in the world do you do if your line goes through 0, 0? Just pick a different point, like 1, 2 or something like that. But this one does not go through there, so let's pick 0, 0. So I'm going back to the original. 0, is that less than or equal to negative 1/4 times 0 plus 2? Really? That's just 0, right? Is 0 less than or equal to 2? it is. Therefore, I shade the bottom left because that's where 0, 0 came from, which is the bottom left. And we'll shade right over the top of 0, 0. You have to look at your directions when you do a problem like this using software. Sometimes you just move a button to shade aside. You don't do all this shading that I'm doing by hand. Okay. Now, let's look at our other line. X plus 4y is equal to 4. Now, I need that y by itself to write this as y equals mx plus b, or you could use the intercept method. But I'm going to move that x over. It's going to make it negative x plus 4. And then I'm going to divide everything by 4. Again, the intercept method would have been just as faster. 4 divided by 4 is 1. So my y-intercept is 1, right here in blue. Now I'm supposed to count down 1 and right 4. Okay? So from the blue, I got a mess going on. I can't even see my xy axis. Down 1, right 1, 2, 3, 4. Down 1, right 1, 2, 3, 4. Now, what do you know about these two lines? By the way, solid or not? Solid, right? How do I know? The less than or equal to. So solid. And what's up with these two lines? If you said they're parallel, you're right. If you look at my graph, they don't even look straight, much less parallel, but they are, just pretend. Okay, now, by the way, my X is missing. How do I figure out what to shade? Well, I've got to shade my blue. I haven't done that yet. Okay, so 0, 0 lies below the blue line. Let's plug 0, 0 into the original inequality. 0 plus 4 times 0. Is that less than or equal to 4? Yes, 0 is less than or equal to 4. So I shade below the blue line. Okay, so now my answer, it's really hard to see what my answer is, but my answer, remember the red is shaded below the red line. It kind of did a lousy job right up against the line, but it goes all the way right up against the line. Okay, all that's included. But what shaded both colors starts at the blue line, including the blue line, and goes down. So basically it's the same as what shaded for the blue. Now you will have problems that shaded what's in between. This did not get what was in between, because they were both true statements with the 0, 0. What do you think? You got this? I think you got it. You just got to practice. You might want to go through these again and pause it before I do anything and just make sure you're seeing it the same way I am. But let me know if you have questions.